So good morning everyone. We know that from last time, when a current is going through a magnetic field, there will be a force generated by that current and the magnetic field. Okay. Now, just have a look at this demonstration again. Okay. Sometimes it jumps upwards, sometimes it goes downwards. So the question is, what are the directions of those forces? Okay. Now, the direction of the forces really depends on the direction of the magnetic field and the direction of the current. And there is a way to figure that out. So that's what we're going to learn today. Okay, to find the direction of the forces, you need to use something called the right hand rule. I have it down there. Okay, the right hand rule. So let me just basically explaining it. Okay, now raise up your right hand. Okay, raise up your right hand, and the direction of your thumb, okay, is always the current. Okay, thumb is the current, okay, and the direction of fingers, okay, is going to be the direction of magnetic field. However, the direction of your palm is going to be the direction of the forces. Three basic rules: thumb, current; your finger is the magnetic field; your palm is the forces we push or pull. Okay. Now, have a look at the diagram on your screen. Okay. Now, in this case, I have a magnetic field and a current goes through it. I'm going to find the direction of forces. Okay. I'm going to find the direction of forces of this situation. Now, I have the same question drawing on here. Let's use my right hand rule. Now, say the current goes up, so we put our thumbs in the upward direction. Okay? And the magnetic field goes from the left to the right. Okay? So you can do it now. Do it with the screen. Okay, let's do it together. Now, finger lines up with the direction of the magnetic field, goes this way. Okay. Now, my palm this time is facing into the page. So if I set up something like this, there will be a force generated on that wire go into the page, into that direction. So let's label it on our diagram. So the force, okay, would go into the page. Remember, that's into the page. Okay, with a circle, with a cross, it go into the page. So let me just refresh you with all this. Okay. The top circle with the dot is out of page. It's a symbol for out of page. Okay. This is into the page. Okay, into the page. Okay, let's look at another example. Okay. Now, have a look at your screen. I have a question there. I have the exactly question there. Okay. Now, we have a magnetic field. Okay, goes from north to south. Okay, from down to up, and we have a current goes from left to the right. Okay, left to the right. I'm going to use my right hand rule. Always using your right hand. Don't use the left hand. The right hand. So let's do it. Okay. Now let's say my four fingers, direction of magnetic field pointing upwards. Okay. Current goes to the right, so I need to twist my arm like this. Okay. Then my face comes out. Okay, so that's the direction of the force. It goes out of the page. So let's label it there. Now, the right hand rule is simple and easy to use. Okay, so but the only problem is when you're using it, you need to twist your arm a lot. Okay, so the forces. So all you need to do is do some practice. Just do some practice on twisting your arms. Now we're going to do some more examples. Hi, let's look at this question there. Okay, I have the exactly question on there. Now, so we need to find the direction of forces. Okay, now again, okay, we have, if you're looking at this, okay, we have a magnetic field from north to south, like this. Okay, I need to twist time, if you can say. Now, let's do all this together, okay, from north to south. Then I have a current goes from the left to the right, so it's something like this. Okay. If you can say, well, if you do the same thing, my palm is actually facing downwards, so the force generated must be downwards. Okay. So it's just a matter of twisting your arm. Let me just write this down. So the answer will be B, downwards. Okay, now look at this question. It's the same question as the previous one, but okay, now in this question, what's happened is instead of a DC, we use an AC. What does this mean is, remember in AC current, the current actually flows in the positive direction for half of the period, then flow to the negative direction. Okay? So in this case, what we can say is the direction of currents actually changes. It changes by a frequency of 100 Hz. That means 100 times per second. Okay? 100 Hz, 100 period per second. So what this affect? Okay. Before we used our right hand rule, the force actually goes down. Okay. Now, if we change the direction of current, if I twist my arm like this, my palm, the force on my palm actually moves up. So what does this mean is, the force actually, the wire actually is going to move downwards, then upwards, then downwards, then upwards. They are going to oscillating. Okay, so the question asked me to explain what's happened to the wire. What we do is, okay, it move up and down. Okay, 100 times per second. Okay, yep. Okay, for this question here, yep. Now we have the same diagram, same current. Then we know the force actually goes down. The force actually goes down, and we need to find the strength. The strength of magnetic field. Remember, write this equation down. Okay. B stands for magnetic field in Tesla. So now let's do the calculation. Okay, so we have the length is 10 millimeters. Okay, change it to meters. So 0.01 meters. Current is 1 amp, and the force. Oh yeah, we need to find the magnetic field. So forces is 0.01 newtons. Yep, and stretches the wire. So assume there's only one wire, because n equals to 1. There's only one wire. Now let's do the calculation. 0.01 equals to 1 times b times 1 times 0.01. Okay. Now, yep, my answer is 1. Now, if you confused, okay, of course the unit Tesla, okay, 1T. Just done. Now, write this equation in your summary notes in your cheat sheet. Okay, you're going to need it a lot. Now have a look at this question. We have a wire. The wire goes with a DC current. Okay, so the force is going to acting on only one direction, from west to east, and we have Earth's magnetic field, and yep, the length is 20 meters. Now we need to find the magnitude and the direction. Okay. Now let's find the magnitude first. Okay. Remember your equation: force equals to N B I L. Okay. Write down the numbers. You get your answers in Newton. So your N should be, I believe, should be 1. There's only one wire. So I have 1 times B, so 4 times 10 power minus 5 Tesla times the current, which is 2000 times 20 meters. Okay. Now put it in, you get your answer. Let's find out the direction. Okay. Now in this case, okay, remember that the geographical south pole on the planet of Earth is the magnetic north. Okay, the magnetic north. So what's happening is the magnetic field B is going to start from the south to the geographical north, okay, in this direction. So if we put it in, it will be into the page. The magnetic field actually is going into the page. Okay, according to the diagram there. So let's use our right hand rule. Magnetic field go into the page, current to the right. Okay, you can see the current goes to right, my palm facing upwards. The force goes up. So, yep, and the force actually goes up, down. Okay. Okay, now have a look at the question. We have north to south. Okay. Pause the video and read the question if you need to. Okay. So the magnetic field goes from north to south. Okay, we label it B. And we have a force goes upwards. Now the question asks me to find the current flow, whether it flow from A or B. So let's do our right hand rule. Yep. Okay. Now you can do it with me, just to do some practice. Magnetic field north to south. Okay, I have, if you can see, yep, there. Okay, now north to south. Then the force goes to upwards. It's like this. Okay, if I can show you. Then my palm facing, yep, and my thumb is pointing into the page. Okay, so the direction of the current will be into the page. Judging from the diagram, it must. Let me just write it down. Okay. Current is into the page. Okay. That's into the page. Now, yep. So the current flow from A to B, from A to B. Okay. Okay. Here is the last question, last example question. Now, same diagram as the previous question, and we need to find the magnitude of force on the wire. Use the equation, okay, F equals to N, B, I, and L. Okay. N is the number of wires. So in this case, the number of wires is 1. So I have 1 times B is the magnetic field, 2 times 10 power minus 3, and I is the current, 5 amps, and L is the length. It's not the length in the wire. Well, it is the length in the wire. It's the length in the wire that in the magnetic field. Okay, so judging from the diagram, the length of the wire is 40 centimeters. Okay, the wire outside doesn't experience the magnetic field, so we don't want them. Okay, and 40 centimeters is 0.4 meters. Always remember your conversion, your unit conversion. Type it in, and you have your answers in newtons. Okay. Okay. Thank you, everyone, and let's move on to the next video.